Good day, students. I hope everybody is doing great. Today, our strands still remain number. Our substrands here is ratio and proportion. Under this ratio and proportion, we are going to talk about how to compare a given ratio by using less than, equal, or greater than sign. Our lesson has been taken from the new curriculum for Basic 6. Strand number 1, substrand 4, content standard 2, indicator 1. So how to compare ratios by using less than, equal to, and greater than. Good. Let's proceed. The comparisons of ratios by the use of less than, equal to, and greater than. Ratio is the relationship between two quantities which shows that one quantity is being greater than the other. Ratio can also be written in its simplest form. Ratio compare two things of the same kind. Ratio compares two quantities or two things of the same kind by changing to what? To fraction. To compare a given ratio, change all ratios to fractions, then change the fraction to like fraction by finding the LCD, which is the least common denominators, or the LCM, which is the least common multiple. They are the same of the denominators, and then rename the unlike fraction to get what? Like fraction. Then that you can compare. After getting the like fraction, then use the principles of having the same denominators. The one having the bigger numerator is greater to compare. So after getting the like fraction, you want to compare the fractions. We use the principles of having the same denominators. So a situation whereby you have the same denominators, the one having the bigger numerator figure is greater to compare, okay? So we are going to use these principles and then the following steps to compare a given ratios. We said the ratios compare two quantities of the same kind. And before you can compare ratios, the first thing you have to do is what? You change all ratios to what? To common fractions. And then you change all common fractions to what? To like fractions. Because it's likely that the fraction that you change to will be unlike. And you can't compare unlike fraction unless you find the LCD of the denominators. And then you name or you write equivalent fractions for these and you get a like fraction. After getting the like fraction, you are going to base on the principles because the like fractions are fractions with the same denominators. Then you consider only the numerator, the one having the bigger number here is greater, okay? So the one having the bigger numerator is greater, that is what you're going to base on. A situation whereby you have a like fraction. Without wasting my time, let's solve one or two examples here. Okay. Good. Now, example. Use less than, greater than, equal to compare the ratios below. Now, you are being given 3 to 5 against 2 to 7. We are asked to choose the one that is greater here. Because you cannot use your naked eyes to determine the kind of ratio which is bigger here. So the best thing you have to do is that you change all ratios to what? To fraction. So let me write the solution here. Okay. Then you change all ratios to fractions. So change to fraction. Okay, good. Now we are going to change the 3 to 5 against 2, 2 to 7 to fraction. Good. So here, to change them to fraction, the 3 to 5 is what? 3 over 5. That is 3 over 5. Okay. And then against 2 to 7, when you change to fraction, it will be 2 over 7. Okay. Good. Now, because these fractions here have different denominators, they are what? Unlike fractions. So you have to change unlike fraction to what? To like fraction by finding the LCD. So you change to like fractions by finding the LCD of 5, 7. Okay. So you're going to find the LCD of 5 and 7. So whether you use the multiples method or use the prime factorization method to find the LCD, the multiples method, when you have the 5, start with the 5, the multiples of 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. Okay. Then we list the multiples of 7. We have 7, then 14, 21, 28, 35, 42, 49. Then you leave 3 dots, indicating that there's a continuity of this one. You can continue later because a multiples has no end. Okay. So here too, you must also leave you leave indicators to show that there's a continuity of that. The multiples has no end and they are endless. Okay. After finding the multiples of each of the numbers or each of the denominators, then you find the common multiples. The common multiples, which is the CM. Okay. The CM. And that is the numbers that appears in the multiples of 5 and at the same time multiples of 7. And I hope we have 35. Okay, so 35. And then when you continue, you definitely get 70. Okay, good. Then within this common multiples, you list the least one in the common multiples. And once we have 35 to be the least here, so the least common multiples will be 35. Okay, good. So now our LCM, which is the same as LCD, is the same as what? The least common multiples or the least common denominator is what? Is 35. Okay, good. This method here, we call it what? The multiples. The multiples method. Okay, good. You can also use the prime factorization method, okay, to also find the LCM. So I also use the prime method, okay, to find the LCM. Good. And that one too, you make a simple table. The denominators here is 5, and the other one is 7, okay? Then you find a number to cancel the 5 and 7 at the same time. If there's nothing like that, then you use the numbers themselves, okay? So because we don't have any common factor to cancel the 5 and 7 at the same time, we are going to use the 5 to cancel itself, okay? Good. So 5 goes here, 1. 5 cannot cancel 7, so you have to repeat the 7. Then you choose 7 to cancel itself here. 7 goes here, 1. And therefore, the LCD here is equal to 5 times 7, and that is what? 35, okay? So what is the meaning of this 35? What the essence of calculating this 35? Because the fractions given here, which is 3/5 and 2/7 are unlike fractions. So we want to choose a common denominator, or we choose one denominator so that we can rename these fractions to get the same denominator to be 35, 35. So our new denominator for both fractions here is supposed to be 35. So let's take the fraction themselves and rename them so that they will have the same common denominator. So here, when you take the 3/5 here, let me write on heading as well. So this process of renaming, we call it renaming, okay? Renaming. That one too, we can also call it writing their in equivalent form, writing them in their equivalent form. So when you take the 3/5, we said you leave a space, okay? Then our new denominator here is supposed to be 35, okay? Good. Then when you take the other fraction, which is 2/7, you leave a space, okay? we leave a space here. Then the new denominator that will make these two fractions be like fraction is what? Is 35. Okay. That is why it must be equal to the LCM or the LCD that you find. Are you okay? Good. Now let's do small statistics. Good. Now the denominator, the old denominator here is 5. The new here is 35. So times what number do you think that we got the 35? So here times 7. Okay. And what you do to the denominator must be done the same thing to the numerator. So here will also be 7, okay? And therefore 3 times 7 here will give you what? 21, okay? Good. So this time 3 over 5 is now renamed to 21 out of 35. Is equivalent of 3 over 5, okay? Good. It's the same as that. Then when you come to the other one here, we have the old denominator here to be 7, and we said the new denominator that will make the two fractions be like fractions is that it must be 35. So with the old and the new, you multiply the old by what? 5. Okay, good. The same number must use to multiply what? The numerator, which is 5 here. Okay, good. Now we have 2, 5 here will give you what? 10. Therefore, our new fractions have been what? 21 out of 35 against 10 out of 35. Now, they have the same denominators. And the principle says what? A situation whereby they have the same denominators, we only compare the numerators. We only compare the numerators. The one having the bigger number is greater. So therefore, 21 is bigger than 10. So the entire 21 out of 35 is greater than 10 out of 35. Therefore, you turn them back to what? To the original ratios here. So the question was asked in the ratio form. So when you finish, you must also turn your answers to ratios. So here, the ratios was what? It was 3 out of 5. Okay, good. And then this one too was also 2 out of 7. Therefore, 3 out of 5 or 3 to 5 is greater than 2 to 7. Okay, then you are done. Okay, that is how we compare ratios. First, you change to what? Fractions, and then you change all fractions to like fraction, and then you compare. Then you change back to ratios, and then you write your final conclusion. Let's quickly solve one more examples here. Example, arrange the ratios below in both ascending and descending order. So it's also comes with what? The comparison. Before you can arrange something in ascending from the lowest to the highest, descending from the highest to the lowest, you need to compare and choose the one that is greater or the one that is smaller here. So here, let's write our solution here. Okay, great. Solution. Now you change all ratios to fraction, okay? Change all ratios to fractions. So change all ratios to fractions first. Good. Now with this, the first ratios here is 7 to 5. 7 to 5, when you change to fraction, is 7 over 5. Okay, good. Then the second ratio here, which is 4 to 3, the fraction is 4 over 3. Okay, good. And then the fraction for 3 to 5 here is what? 3 over 2. Okay, good. Then, because these fractions here have different denominators, here is 3, here is 2, and here is 5. Then you change all the denominators, or you change all these fractions, which is unlike fraction here, to like fractions. So let me write change all. Okay, change all to like fractions. Okay, so you are going to change all these fractions, which are unlike fraction, to like fraction by finding the LCD or the LCM of 5, 3, and 2. Okay, good. Now we are going to find the LCD of this one. Then let's use the multiples method first, or you can either choose to use the prime factorization method. So the multiples method here, good. So the multiples of 5 first, we have 5, 10, 15, 20, 25, 30, 35, 40, 45. Then put dots to indicate that you can continue from then. Then the multiples of 3, we have 3 here, 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36. So you can also put a dot here. Then stop. Then the multiples of 2, we have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 36, 34 times. Then you can also put dots indicating that you can continue, or the multiples has no end here. Okay. After then, find the common multiples here, which is the CM, and then we have the 30 throughout. When you continue, you will definitely get 60. Okay. Good. And then you stop. Then you have the LCM, the least in common multiple. Once we have the 30 to be our least here, so the least in common multiples will be 30. Okay. Good. Good. So this method here is the multiples method. So let me write on top here. So the multiples. Good. Now we can also use the prime factorization method. Prime method to also find now with the prime factorization method, you need to do a simple table. Okay. Now the denominators are the 5. Okay. And here you have the 3 and you have the 2. Okay. Then you find a common number to cancel all these numbers at the same time. If not, then you consider the 2, whether you can cancel 2 at the same time. If not, then use the numbers themselves. So here, there's no way you can cancel the 3 numbers at the same time, 5, 3, and 2. And there's no way you can either cancel the 5 and 2, and then 5 and 3, or 3 and 2. Then you choose the numbers themselves first. So here, the 5 cancel itself 1. 5 cannot cancel 3, so we have to repeat the 3. 5 cannot cancel 2, you have to repeat the 2. Okay. Then once you have gotten 1 here, we have done. Then you choose the 3 to cancel itself to get 1. So 3 goes here 1. 3 cannot cancel 2, you have to repeat the 2. Then you choose the 2 to cancel itself to get 1. 2 goes here 1. Okay. Therefore, the LCD here is what? Is 5 times 3 times 2. Is the multiples of the number that we use to cancel the given denominators. Okay. And 5 times 2, 5 times 3 here is 15, times 2 is 30. Okay. Good. Now, the meaning of this 30 is to make sure that the new denominators must be 30, 30. So the 30 here stands for our new denominator for these fractions, so that they will all be like what? Fraction. So all of them are they going to have the same denominators by renaming them to make sure that they have 3030 as their new denominator. And that process, we call it renaming. So you write on top here, renaming. Okay. So renaming, naming, or expressing them in their equivalent. Okay. So you are going to rename these fractions here. You make sure that their new denominator here will be what? 3030. So when you take the first one, it's 7 out of 5. The new denominator, you leave a space. The new denominator here must be 30. Okay, must be equal to the LCM. Then when you take the 4 out of 5, 4 out of 3 rather, we leave a space. The new denominator here must be what? 30. Okay. Then when you take the other fraction, which is 3 out of 2, the new denominator here must be 30. Okay. Now let's back to the first one and do small calculations here. Now we have the old denominator with this fraction 7 out of 5. We have the old denominator is 5. The new one must be 30. So it means it was multiplied by what number? So the 5 times what number give us 30? That is 6. Okay, good. The same number must be used to multiply what? The denominator. The denominator was multiplied by the 6. So the same number must be used to multiply what? The numerator. Okay, good. So the 6 must be used to multiply the numerator here, and that one too. Therefore, our new numerator will be here, will be what? 42. Okay, we have the 42. 6 times 7. Okay, that is 42. And then we come to this side. Now we have the 3 times what number that gave us what? 40 times what number that gave us 30. So it means the 3 was multiplied by 10, that we were able to get 30 here. The same 10 must be used to multiply the numerator here, and therefore you can get the new numerator to be what? To be 40. Okay, good. Or 4 times 10 will give you 40. Then you come to the other one. 2 times what number? Sorry. 2 times what number that we gave 30? 2 times 15. Okay. The same 15 must use to multiply what? The numerator, so that we can also get what? The new numerator for that. Okay. And that one, when you multiply to, you get what? 15 times 3. So here you multiply here 2 by 15. And that one too is what? 45. Okay. 2 is 45. Good. Now we have gotten the same denominator to be 3030. So therefore our fractions here are 42 out of 30, which is also greater than 40 out of what? Now we have 40 out of 30. And then we have the biggest, most one is what? 45 out of what? 30. Now I'm going to do the comparisons here. Now, since they all have the same denominator to be 30, 30, then you consider the numerators. The one having the bigger number is greater. Okay, good. So when you are asked to arrange in descending order, because we have 42, 40, and 45. So the 45 out of 30 will count first. So let me write here descending order. Okay. So from the biggest to what? To the lowest. So now we have 45 out of 30, which is greater than, then followed by the 42 out of 30, which is also greater than, then 40 out of 30. Okay, then you write them in their ratio. So here is 45 out of 30 was derived from 3 out of 3 to 2, okay, which is greater than, then the 42 was also derived from 7 to 5, okay, good. And then the last one, 40, was also derived from 4 to 3. Now, with this, we have done. So always after using the fractions to choose the one that is greater, later you convert them to ratio, like 3 to 2 is greater than 7 to 5, which is also greater than 4 to 3. When they ask you to arrange them in ascending order, so with ascending order means from the smallest to what? To the biggest. So without waste my time, the 4 to 3, which is less than 7 to 5, which is also less than 2, 3 to 2. Okay, good. So this is how the ascending order also will be. Okay, good. Thank you for watching. Okay, good.